Greetings! If you watched this video until the end, you will learn what is encapsulation, what is inheritance, what is polymorphism, and what is abstraction in object-oriented programming. My name is Nikolai Suridov and I'm backend developer on Python. And let's start from what key concepts do mean. So, key concepts are the fundamental principles on which this programming paradigm is based. These principles help structure and organize code, making it more understandable, modular, and easier to maintain. And classically, three key concepts are distinguished. It's encapsulation, inheritance, and polymorphism. And also very important concept is abstraction. And of course, we will talk about abstraction too in this video. But before we move forward, I want to know, have you ever had experience with the key concepts of object-oriented programming during your job interviews? Put your answer in the comments. So, and now let's talk about encapsulation. Encapsulation is the combination of data and methods that operate on that data within a single class. And here I want to highlight this very important moment because during interviews it's often candidates answer that encapsulation it's about hiding some implementation from the user, but this is not the correct answer because it's the only manifestation of encapsulation, but not encapsulation itself. And why do we need encapsulation? Encapsulation allows protecting the internal states of objects, encapsulation maintaining data integrity, and reduces system complexity. And let's have a look to our well-known class triangle with our three fields, one field per each side of our triangle, and our methods of our triangle, such as calculate area, calculate perimeter, and set methods for our fields. And here, encapsulation in the triangle class can be implemented through using private attributes to restrict direct access to side data, methods to manage access to side attributes, and methods to obtain information about the area and perimeter. And let's have a look to the implementation of our class triangle. Here we have our init method, which represents setting of our initial values for our object. And we have other methods to obtain or to set our field values. Furthermore, we have our area calculation and perimeter calculations to get the relevant values for our shape. And that fact that we work within these methods with the data in our fields, this is a manifestation of encapsulation. And another manifestation of our encapsulation that we have doubled underscore for each of our fields. And that way we restrict the direct access to our field by anybody. And of course, the same situation we can represent in our rectangle class. Number 2, inheritance. This is a mechanism that allows one class, derived or child, to inherit properties and methods from another class, base or parent. And why do we need an inheritance? Because it allows us to reuse our code base and simplifies the extension and maintenance of our software. And let's have a look to our diagram. Let's imagine that we have our well-known classes rectangle and triangle. And of course we have some common features for both of these classes, which can we move to the side of shape class. And here in shape class, we have two types of our methods. First type of methods, it's just the declaration of our interfaces, which have to be implemented in our child classes if we want to use them. The good examples of these classes are calculate area and calculate perimeter. We have no concrete implementation in our class shape, but we have to implement it in our child classes, such as rectangle or triangle. But if we're talking about second type of our methods, such as compare area and compare perimeter, we know how to do that even on the level of parent class. For example, I know how to compare perimeter of two rectangles or two triangles or triangle with rectangle, and that's not a problem for me. I can compare different shapes to each other. The same situation I have with the perimeter. And let's go to our code base. Here we have parent class shape, where I implemented two interfaces for my area calculation and perimeter calculation. And here, within that methods, I raise not implemented exception and show to my user that method should be implemented. That means that within my child class, such as triangle, I can override my method calculate area and calculate perimeter and put here all of my business logic. And the same picture I have with my rectangle class. And let's go back to our shape class and check our compare area and compare perimeter methods. These methods are implemented in our parent class, and within them we use, which we know that they exist in our child classes, such as calculate area or calculate perimeter, and we can call them in our parent class without any problems. And these two methods, which we are implemented on the side of shape parent class, not to duplicate code in our child classes, such as triangle, rectangle, or whatever. Number 3, polymorphism. This is an ability of objects of different classes to process data through a unified interface. It allows the same method to work differently depending on the object that calls it. And why do we need polymorphism? Because it allows us to write more generalized code and simplifies the development process and reduces code duplication. The same like inheritance in that way. Let's have a look to the diagram. So, let's imagine that we have our well-known classes rectangle and triangle, and we have calculate area methods within both of them. But not only rectangle or triangle can calculate area for themselves. Just imagine that according to business logic of our application, we need to implement a new class package with the same method calculate area. And then we want to use all of these classes within one scope of business logic. So in other words, we have different classes, including those that are not related, can implement the same interfaces. And let's have a look to the code base. So here we have our rectangle class the same way what we have before. And let's have a look to the class package, which implements the same method. So, and here let's have a look to the package class, which is not a child of our shape class, which we have before when we work with a rectangle or triangle. And here, within our package class, we have our method, calculate area. And let's imagine that during our business logic, we need to work with a list of elements of different types, but rectangle, triangle, and package simultaneously. And we want to calculate area of all of them and maybe send this data to the database, for example. And here, because of that fact that we have the same interface implemented in every class, despite of that fact that they are not related to each other, we still can call the method calculate area. And before we move forward, I strongly recommend you to join our GitHub repo, where you can find all of the origin code base of our videos. And the last superstar, this is an abstraction. Abstraction is the process of identifying common characteristics of objects while hiding implementation details. And why do we need an abstraction? Number 1, because abstraction allows us focusing on the most important aspects of an object. Second, it simplifies the development and use of data and use of classes and objects. Abstraction helps reduce system complexity and improves code understanding and usage. And let's have a look to the diagram. Here we again have our well-known classes rectangle, triangle, and parent class shape. And here we have also our well-known methods, calculate area and calculate perimeter. And here the main idea that our methods on the side of shape, they are defined abstractly and must be implemented in some classes. And of course, on the side of class rectangle and triangle, these methods are defined concretely. And let's have a look how it can be implemented in our Python language. So, we have our well-known triangle and rectangle without any changes. But on the side of shape, we have our abstract method calculate area and abstract method calculate perimeter. And by this decorator abstract method, we set the rule for our child classes. And it tells us that it would be impossible to create an object of triangle or rectangle or whatever if we haven't implemented the concrete implementation of calculate area and calculate perimeter methods. And here, this is the main difference between our inheritance example, where it was possible to create our shape or triangle objects even if we haven't implemented our methods. But if we use abstractions in Python, it wouldn't be possible. And as a conclusion, encapsulation, inheritance, polymorphism, and abstraction are the main pillars of object-oriented programming. They contribute to creating flexible, modular, reusable, and easy maintainable code, and the pillars of object-oriented programming make it a powerful tool for developing complex software systems. And that's it. Please like and subscribe to my YouTube channel, and also put your comments below this video. Goodbye.